Okay, so these shouldn't be all that challenging. I think for a lot of you the hardest part is when it shifts you back and suddenly you've been using these and then you have to go back and use one of these and you fight it because you've been using the more complicated equations. So this is sort of the baby step of what I'm going to tell you. You'll see more of it tomorrow because I'm going to have the 2C and 2D worksheets for you tomorrow, and we'll have odds on those, so it'll add probably about 8 problems. The thing to do with every single one of them, like I said, over half of physics is good bookkeeping, is literally listing what you have. So for the 2 students who are walking at different rates and blah, 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 when you realize, oh, well, I have the average velocity for A, I have the average velocity for B, I have the distance, well, there's going to be a delta, there's going to be a delta T for A and there's going to be a delta T for B. Right there, what that tells you is you have to use this because the only things that you have are variables that come from that equation. You don't have an initial, you don't have a final, you don't have a rate of acceleration, you have none of that. So you know that you have to use that equation. And that's, with these problems especially, it sounds like, you know, the secret of the universe. It's one of these things where you send in $20 for the secret to making $1 million, and it's that you take out an ad and you tell people to send you $20 for the secret to making $1 million. It seems really simple. It seems really obvious. When you write down the variables, it will tell you which equation you're using. And we haven't gotten into a whole lot that are real free form where you could be using any one of the 4, but in every case, once you list your variables, it will lead you to an equation because you'll say, oh, well, I've got these 3 things and I'm looking for this thing. Well, that means I could only use this equation. Or, you know, I have these 3 things and I'm looking for this thing. The only possible equation I could use would be this one. So are you starting to feel that yet? Are you starting to get the hang of that yet? I think that really comes into more force on C and D. And in the book where they have it broken down, it's really not mixed review. It's very much, here's an equation, here are 5 problems that use that equation. Here are 5, you know, here's an equation, here are 3 problems that use that equation. And where it gets more challenging, of course, and where you're going to have a test, of course, where it's all mixed. And I don't tell you, these 3 problems use this equation. You have to figure that out. So that's the big first problem-solving thing, is that bookkeeping. Are there any that anybody wants to see worked out or partially worked out? So we're looking at problem 9 on the 2B worksheet, number 9 on the 2B worksheet. In 1993, bicyclist Rebecca Twigg of the U.S. traveled 3 kilometers in 217.347 seconds. Suppose Twigg travels the entire distance at her average speed and then accelerates at negative 1.72 meters per second to come to a complete stop after crossing the finish line. How long does it take Twigg to come to a stop? This is fantastic. So what they're telling you, what they're really asking you is all about after she crosses the finish line. And I'm going to take a picture of this because I want to show you something. A lot of it's garbage. We actually don't care that she traveled 3 kilometers in that many seconds. What we care about is that she's at her average speed and then she accelerates at some rate and comes to a stop. And what we want to know is how long that period of acceleration is. So what do we have? Let's list it. Well, basically we have a VI, which is her average speed that you figured out from her 3 kilometers in 217 point blah 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 seconds. You have a VF, which is 0. You have a rate of acceleration, negative 1.72 meters per second squared, and what you're looking for is a delta T. So which equation does that lead you to? Well, let's see. I've got VF, VI, delta T. Okay, what about this first one? No, because I don't have delta X. Okay, can't use that. VF equals VI plus A delta T. Hey, there's our winner. So the only catch is that you do have to figure this out. So I guess I shouldn't have said that that was total garbage, because you do need it to figure it out, but it's not really what the problem's asking for. So you have to use this part to get a VI, because they're telling you that that's what she's starting at. Does that help? Here's my thought process right now for the next couple days. Tomorrow, I'm going to have the 2C and 2D worksheet for you, and then we'll work on that, ask questions, do kind of what we did today. Wednesday, you'll have a FIP quiz. Thursday and Friday, we're going to whiteboard your FIP quiz. So, you know, you won't have, here you've got the correct answers, you know what you're working for. On the quiz, you don't know if you got it right or not. So, you'll take the quiz, and then Thursday, you know, they'll be collected. I'll be out Wednesday because I have to go see my surgeon. They have to look at my neck and see if it looks good. The sub will collect the quizzes on Wednesday. Thursday, we'll pass them back out. You and your group can compare notes, and you will whiteboard the problems for one another. So you will get to the correct answers by the end of Friday, and then we'll go over them. So that's the plan. I think that's how the whiteboarding will work best.
My brain's working really slow today.
It's okay. It is Monday. We allow slow brains on Mondays.
I was up thinking last Saturday.
I bet a lot of you were.
And I think I read somewhere that it normally hits you not the next day, but the day after that.
What does?
Sleep loss. There's also a cumulative effect. You can build a sleep debt, and you cannot, you really can't physiologically repay that sleep debt. Like, you just have to keep up.
That's kind of what I have. Like I normally like halfway through the summer is when I eventually start catching all my sleep. But like the beginning of the summer, I'm still like sleep deprived for the longest time.
So we're still running. If you have not taken, whoops, that's, no.